ladies and gentlemen, welcome back for another round. This is Mr. Doolin. I thank you so much for tuning in. What we're going to do today is we're going to take a look at reaction mechanisms. Now, reaction mechanisms, if you want a definition, they represent the sequence of bond breaking and bond making steps that occur during the conversion of reactants to products. So again, reaction mechanisms represent the sequence of steps of bond breaking and bond making steps that occur during the conversion of reactants to products. So there's another mental hump that we have to get over here. You know, we try to get over this mental hump in kinetics where we get to the idea that the basic idea of a reaction is that two elements or compounds actually have to physically collide in proper orientation with enough energy to actually cause a reaction to occur. Well, it might not be that easy. If I'm looking at the reaction A plus B gives me C plus D. Now, a lot of people, when they see this, they're starting to say, okay, well, A's got to run into B, and then you'll form C and D. Well, that might not actually be the case at all. And so what we have to start getting to the point is understanding is that a lot of my reactions are made up of a series of steps that occur, and then, you know, you look at the difference between beginning and ending, and you've got this, bam, you got this reaction, and we'll just write because everything in between cancels out. And so step one for this might actually be 2A gives me E plus C. And then some people are going, wait a minute, what's E? E's not up there, all right? Well, maybe in step number 2, we would go E plus B gives me D. And what we can do is we can see if we were actually to add up both of these steps, both of these sub-reactions, if you will, that we would end up with, and maybe I want to make that just, maybe I'll do E, there you go, because that cancels out, that works. And so I would end up with A plus B gives me C plus D. E actually ends up canceling out. And this is actually an important term that we're going to need to know. Notice E wasn't present at the beginning, but it was produced in one step and then later consumed in another. There's a term for that. It's called a reaction intermediate, and that is actually a term that you'll need to know. So a reaction intermediate is produced in an early step and consumed in a later step. You'll need to know what that is, all right? Okay, and so again, we've got to get over this idea that our overall reactions might occur in a series of steps, and what reaction mechanisms are going to do is they're going to focus on what are these series of steps and how do they affect the overall rate of the reaction. All right, so a couple of things about these reaction mechanisms, because we are going to use them to determine an overall rate law, is that reaction mechanisms must be determined by experimentation. You have to. You can predict and kind of guess what they might be, but until you verify them experimentally, it doesn't amount to a hill of beans, all right? So number 2, they must agree with the overall stoichiometry of the reaction. Like in this particular case, if I wanted to write a rate law for this, I can't have E in it because E doesn't come up with my overall stoichiometry. It's not even present in my overall reaction, so I can't have a rate law based on E, all right? And then number 3, it must agree with the experimentally determined rate law. I.e., we will do the experimentation. 1 and 3 are kind of the same to me. All right? Okay, and so now for some vocabulary. What we're going to do is we're going to call these steps, we are going to call them elementary steps. Or you might see them referred to as elementary reactions. And elementary steps or elementary reactions are just the series of reactions that occur during the process of an overall reaction. Now, another term that I'm going to introduce here, and I'm actually going to erase the bottom of this off because I just want to talk about just the elementary reaction. So there's a term here that's called molecularity. And what molecularity describes is the number of molecules that participate in an elementary step. So notice in step number 2, I actually have 2 molecules participating there. So what I would call that is bimolecular. And so a bimolecular elementary reaction has two reactants that participate in that particular reaction. The other molecularities that we need to be familiar with is unimolecular. There you go. And that's just if a single element is just going to break down and decompose. And we've got bimolecular, which we just talked about. And then there's also termolecular. And what that means, termolecular, is I have 3 or more elements that actually are participating in the reaction. I'll be honest with you, termolecular, we'll go through some demonstrations with this in class. Termolecular does not happen very often because it's actually very, very rare that we'll get 3 or more elements combining with proper orientation and energy to get a reaction to occur. All right? Okay. And so the other reason, one of the reasons what we're actually concerned with the molecularity is based on molecularity, elementary steps are going to tell us a lot of things. They'll help us determine the rate, but coefficients in elementary reactions actually are orders. So we are taking a look at our rate law and our integrated rate law, and we're looking at graphs and we're looking at tables of data to figure out orders. If we have a reaction mechanism, it becomes really easy because the coefficients actually are the orders. So for example, if I'm going to take a look at this reaction, 2A gives me E plus C. Let's do that. How about E plus C? If I'm going to write a rate law, if this is my rate determining step, I'm going to write a rate law and say rate is equal to my rate law, and then it would be A squared. Because this is bimolecular, all your bimoleculars are going to have a rate law that's going to end up being overall second order. And it's just the way that it is. Now, rate determining steps, as you heard me mention it a second ago, a rate determining step is the slowest step inside of your reaction mechanism. And we all understand this, right? A rate determining step, I can't go any faster than my slowest step. And so that rate determining step will determine your overall rate law. So if I can look here and say step 1 or step 2, which one's my slow step? It'll help me determine which one is going to determine my overall rate law. And since I know the reaction mechanism, I can actually just write it out. All right? Okay. So there's actually a couple of different scenarios, and I know I'm going through a lot here, but there's a couple of different scenarios here where we'll see these rate limiting steps. And so the first scenario is I've got a slow first step, because we can have as many elementary reactions as it takes. You can have 2, you can have 3, you can have 4, you can have 5. As many as it takes, you're going to have a rate determining step. Now, if your rate determining step is your first step, we just look at the stoichiometry of that elementary reaction. The molecularity determines the rate law. Easy peasy, simple as it gets. All right? Now, the other one that's a little bit more complicated is if I have a slow second step. And what that means now is that I'm going to have a buildup of products from the first reaction. I'm going to form an equilibrium there, and determining the rate law becomes a little bit more complicated, and we have to start looking for intermediates and catalysts and things like that to make sure we're not including them within the rate law. Now, the slow second step, what we're going to do is I'm going to go through those examples with you in class. I'm not going to try to explain that in under 2 minutes here in a lecture because it'll just confuse you. All right? And so we'll see those examples in class, but you just need to understand when we're looking at reaction mechanisms, really what we're trying to do is determine a rate law, right? And to do that, we need to know which is our rate determining step, and there's a couple of different scenarios where we will be looking at rate determining steps. We'll be looking at a slow first step or a slow second step. All right? Okay. Ladies and gentlemen, that was quite a bit. Hopefully you got it down. If you had some questions, get those written down as well. I'll see you in tutorials for those, and otherwise I will see you in class.